Hi guys, so here is Lechattellier's principle. So you've got reactants and you've got products. And remember, the whole idea of Lechattellier's principle is that a change in any factor that affects the conditions of equilibrium will result in the equilibrium trying to do the opposite of whatever it is that you tried to do. So if you try to add something, it's going to go to the opposite side. So if you try to add a reactant, for example, then it's going to go over to the products side. If you try to add a product, it's going to go back over to the reactants side. If you try to steal a reactant, it's going to say, hey, where's my reactant? It's going to try to make more of that. So if you try to steal something, it's going to go to the same side. If you try to steal a product over here, then it's going to try to make more of that product, and it's going to go back over to the right-hand side. Remember that heat is also a factor. If heat is over here on the left, then that would be a delta H of a positive or endothermic situation. Then heat would be left. If you added heat, it would go to the right. If you subtracted heat, it would go to the left. If, however, heat is a product, if heat is over here on the products side of things, well, that means it would be a delta H value that is negative, or it's an exothermic situation. If you add heat, it would go to the opposite side. If you would take heat away, it would go to the same side. So the heat follows the same rules. And then the last thing is gases. Whichever side has more gases, it will shift accordingly in order to increase or decrease the pressure. So if you have gas plus gas comes over here to gas, and you take the volume and you make the volume go down, well, that's going to increase the pressure. Well, if you are increasing the pressure of the system, how does the system get rid of pressure? Well, it goes to the side to the right because there's fewer gases over there, and that's the less pressure. If you were to have a situation where you were to increase the volume, by increasing the volume, you'd be decreasing the pressure. The system's going to say, hey, you're making my pressure go down. I'm going to try to do the opposite. I'm going to make the pressure try to go up. How does this system make the pressure go up? Well, it goes to the left-hand side because there's more gases that are over there. And if there happens to be a situation where there are the same gases on both sides, then Kc equals Kp, and changing the volume up or down will have no effect. So that's a quick recap of Lechattellier's principle. Now, basically what you have to do is you have to figure out in each particular question, is the change that they're making going to have an effect on the equilibrium? And if so, what is that effect going to be? Add, opposite, remove, same kind of a thing. So let's look here at number one. It says that we're going to create ammonia in the presence of a powdered osmium catalyst. Remember, catalysts have no effect on the equilibrium, so catalysts do nothing except get you to equilibrium faster. Which of the following changes would result in more NH3? Okay, so basically they're saying, what could we do to send this over here to the right? Please note that delta H over here is less than 0. It is an exothermic process, so that means heat is over here on the right-hand side as well. All right, so what are we going to do to be able to send this guy over here to the right? Will replacing the powdered osmium no, we don't care. That's not going to do anything as far as the equilibrium is concerned. Will increasing the temperature? Well, if I increase the temperature, that's going to send it back over to the left, so that's not the correct answer. That's no good. Will adding some nitrogen do it? Oh, yeah, that'll do it. So if by raising the nitrogen add, it'll go to the opposite side, and that's what we want, so that's your guy. What about removing the hydrogen? Nope. If I remove the hydrogen, it'll try to go back over to the left, and that's not the direction that we want. So your answer is this guy here.